Let's face it, EVs aren't catching on as much as everybody hoped. Their high price tags, slow charging times, and somewhat limited range have been among the biggest setbacks for EVs, all of which stem from one singular issue: batteries. However, Tesla has just announced a new battery that could resolve these issues and spark a new EV revolution. Say hello to Tesla's Diamond nuclear battery. Let's explore what makes it such an impressive innovation. But before diving into Tesla's new battery, it's important to understand the concept of diamond batteries and why they're so remarkable. Nuclear diamond batteries, also known simply as diamond batteries, are a proposed type of battery that uses radioactive energy along with artificial diamonds to generate electricity. The idea is that these batteries will be mechanically simpler, with less stress on components, thereby increasing their longevity and reliability. They utilize the carbon-14 isotope, a radioactive material known for its decaying properties. Over time, the carbon-14 isotope decays, releasing beta radiation. This is where artificially made diamonds come into play. Due to their structure, diamonds are excellent at absorbing radiation. The beta radiation interacts with the diamond, producing a small electrical current. Because carbon-14 decays very slowly, this process can technically last as long as the isotope's half-life. As a result, these batteries can last for extraordinarily long periods and would practically never need to be recharged, addressing the long-standing issue of EV range and autonomy. Additionally, these batteries are practically indestructible and resistant to regular wear and tear, although mechanical damage could render them less effective or entirely non-functional, something true for all batteries. On top of this, diamond batteries could have a significant positive impact on both the economy and the environment. Since they wouldn't need frequent replacement, older batteries could be recycled and used in new vehicles. Moreover, they are more eco-friendly to manufacture, as they don't require highly polluting industrial excavation or filtering. Their energy density could also theoretically reach levels tens or even hundreds of times greater than conventional batteries. These benefits have caught the attention of many companies, with Elon Musk being a prominent advocate for exploring their potential. Tesla has been searching for alternatives to address issues with its current battery production, particularly with the 4680 batteries. Elon Musk has publicly acknowledged significant production challenges, which have hindered the efficiency of Tesla's Giga Texas factory. The inability to produce the Model Y quickly and efficiently has turned the factory into a financial burden for the company. In response, Musk has taken drastic measures, including firing key personnel responsible for the 4680 battery project. Additionally, lithium-ion batteries have come under scrutiny for their environmental impact, as their production emits large amounts of CO2 and is highly toxic to the environment. This has further motivated Musk to explore alternatives, including diamond nuclear batteries. If successful, Tesla's diamond nuclear battery could revolutionize the EV industry. A vehicle equipped with such a battery would theoretically never need recharging, eliminating the infrastructure required for conventional EV charging and significantly reducing the environmental footprint of EVs. The implications extend beyond the automotive sector. For example, SpaceX could use these batteries to power spacecraft on long journeys, as they require little to no recharging and can generate power over time through the natural decay of carbon-14. Despite their promise, diamond nuclear batteries also come with challenges that must be addressed to make them viable for mass adoption. Incredible in theory, these batteries have huge problems that are very hard to sort out. You see, despite nuclear batteries having high energy density as well as excelling at providing consistent and constant low-power energy, these batteries struggle horribly to provide the high power output needed for EVs, which is one of the key reasons why they aren't used or largely developed for such an occasion just yet. Sure, these issues aren't end-all be-all. However, fixing or overriding these issues is a very complex process that needs quite a bit of time. In addition to that, The public is very skeptical when it comes down to both nuclear energies, let alone having a practically irradiated battery sitting under your butt. Now, rest assured these batteries are designed with maximum safety in mind, as diamonds are incredible at containing the radiation within these layers. The biggest issue is going the route of batteries that use alpha particle-emitting isotopes. Alpha particles are easy to stop, even with a sheet of paper, and our skin would most definitely stop them from creating any issues. However, inhaling alpha particles could lead to fatal outcomes. And while sure these batteries will be well tucked in, a serious collision could lead to the driver and the surrounding people inhaling alpha particles. That said, batteries that rely on beta particles are not just safer than these batteries, but are also a lesser health hazard than both lithium-ion batteries as well as internal combustion engines. This is because they have no moving parts, such as a nuclear reactor. This means that there is a 0% chance of the battery overheating. But finally, and most importantly, these batteries will never be cheap, and this is something that simply ruins the perception of them. You see, the biggest issue with lithium-ion batteries is the fact that they are extremely expensive and keep the price of EVs very high to the point that it is rather redundant to buy a cheap-to-run vehicle if you're going to pay 50% more for it compared to a regular vehicle. The same is true for nuclear batteries. Sure, if the standard of living keeps going up, and if we start growing as a society altogether, these batteries will have a place for us. However, now that isn't happening, quite the opposite. That is why we believe that despite the hype surrounding them, nuclear batteries will not be used, at least not in EVs. That said, we are certain that as soon as Elon develops a functioning version of it, he'll start fitting it to his SpaceX spacecraft. In this case, nuclear batteries do make a lot of sense, as they would essentially allow us to retain constant power and communication with various spacecraft, most notably intergalactic and interstellar ones, for decades and centuries on end. But as it stands, the EV won't benefit from these batteries, at least not for now. Instead, what we can look forward to are the rapid further developments of lithium-ion and other already existing battery types, stuff like Toyota's solid-state battery. Whatever happened to the solid-state battery, as Toyota has gone a bit silent recently? To find out, be sure to check out this video.